All right. Well, happy Friday, and today we will introduce NumPy. So we've been covering a lot of the different data structures within Python. So we've covered the list, and we've covered the dictionary and the tuple, and I don't know, strings and stuff. There's there's a few more data structures. There's like sets and things like that. But we'll just we'll kind of gloss over those or skip those for now. Another important data structure is something that's not part of base Python, but we have what's called the NumPy array, the array in NumPy. And so in order to use the array, you have to load a library called NumPy or NumPy. I don't know how to. I think it's pronounced NumPy, but I don't like that. I say NumPy, but anyway, the convention is to call import. You could call import NumPy, but the convention is to do import NumPy as NP. Import NumPy as NP. If you try to do that and you run into an error, just like I did here, I got no module named NumPy. All right, I forgot. I'm not on my home computer. So what you're going to have to do is you're going to have to install it, okay? So I really hope this works. You're going to do pip install NumPy, okay? All right, so we do that. Successfully installed. Okay, all right, so that's good. Let me restart my connection here. Okay, so we're going to restart our kernel, and let's try this again. So hopefully, okay, so now that I've installed it, I don't run into an error here, and I can call numpy _version under version, and it comes back as 2.1.2, which I just installed, and that's what we have. Okay, so again, the command is that you'll open up your terminal. If you try to do import NumPy or NumPy and it says it's not there, the command, you're going to open up your terminal and you're going to do pip install NumPy. Okay, but I already just ran that, so we don't need to do that, and then you'll come back to VS Code or Jupyter. If you're running Jupyter, you got to shut down Jupyter and start it back up. If you're in VS Code, you restart your kernel. Okay. All right. So the data structure that NumPy introduces is the array. Okay. So they're kind of like lists, okay? So like a list, they are mutable, okay? And they're indexed by position, okay? However, the key difference here is that arrays can contain only one data type, okay? So generally, some kind of numeric value, like floats, that's probably going to be the most common, but you can have an array of integers or an array of characters or something like that. Whereas a list, in Python, you can have a list and you can mix characters and string values and numeric values. Okay, so you can kind of mix data types. In NumPy, you cannot do that. They have to be all of the same data type, and this allows for NumPy to do calculations very, very, very quickly and very, very efficiently, because it knows that everything in that entire array is going to be of the same data type, so you can take kind of two arrays and multiply them together very, very quickly. Okay, and this is actually kind of the technology underlying so much of like machine learning methods, because in machine learning you have these giant arrays, okay? And they're in higher dimensions, they're called tensors, okay? So you have these, 10-dimensional arrays and things like that, and you just kind of multiply them all together, and NumPy allows it to be done quickly, which is going to be important. So you can create an array directly by calling numpy.array and then parentheses, okay? So, so you'll go numpy.array, and then you put in, say, like a list or some kind of iterable in there. So here I'm going to put in a list with the values 1, 2, 3 in it, and then this is going to create an array out of that, and we get an array with the values 1, 2, 3 inside, okay? Now, there is a difference when in Jupyter, when it returns the object directly, okay, it's going to say array parentheses, square bracket 1, 2, 3, square bracket parentheses to close that off. Here, if I say we're going to create an array with the same value, but I'm going to call print on it, when it prints, we get, this is the form in which it prints. It prints out with square brackets, but we have no commas separating the values. So, you know, distinguish that from a list. When you print a list, it puts commas in between them, okay? So you'll have to start getting used to or accustomed to kind of the subtle but visual clues that you have, or visual cues that tell you, oh, you're dealing with an array here versus you're dealing with a list, okay? And hopefully you're paying attention so that, you know, when you see parentheses or curly braces, you know, okay, I'm dealing with a tuple. When you see curly braces, I know I'm dealing with a dictionary, okay? Square brackets, you're dealing with a list if you have commas. Square brackets, if there's no commas, it's a NumPy array, okay? Printed array, okay, yeah, if you ask what is the type on A, it's going to come back and it's going to say it's a NumPy ND array. That's the data type, okay? So, says, I wrote in the following cells, I'm going to sometimes just produce the array directly, and sometimes I'll call print on the array and just kind of get used to seeing both kinds of outputs. Okay, what happens if you try to mix different data types? Okay, so here I'm mixing, when I'm during the creation of the array, I've got integer 1, integer 2, float value 3.0, and then Boolean values, false and true, okay? What this is going to do is, again, NumPy requires all the values to be of the same data type. So this is going to what it calls upcast. See? It's going to upcast the Boolean values and the integer values into floats, okay? So in R, we call this coercion. In NumPy, we call this upcasting, okay? And so all of these get upcast into floats. And you can see we have the values 1, 1 point, 2 point, 3 point, 0 point, and 1 point, okay? So the integers 1 and 2 got upcast into floats. And to indicate that they are floats, they are trailed by this little decimal place, okay? And then the false got upcast into a 0, and the true got upcast into a 1. And again, they are float values, so you see kind of this trailing decimal place, right? Here I've got 1, 2, the character string 3, okay? True and false. So these are going to upcast everything into strings. And we get exactly what we expect, I think. 1 in quotes, 2 in quotes, 3 in quotes, and then true in quotes and false in quotes there, okay? You can, the NumPy array is used to create like matrices or just higher dimensional arrays. So these here are, up here, these are just one-dimensional arrays, kind of like a vector in R. And here we're going to create an array that has 2 rows and 3 columns, okay? And so you'll notice I've got kind of double square brackets. I got square bracket, and then square bracket 1, 2, 3, comma, square bracket 4, 5, 6, and then closing square bracket there. So when I print D here, I'm going to get a 2 by 3. And you can see we have kind of 2, in opening we have 2 square brackets, 1, 2, 3, and then 4, 5, 6, and then 2 closing square brackets. So this is how NumPy prints out that you have a 2-dimensional array, 2 rows and 3 columns here. Okay. If you try to do something like this, okay, first row has 3 values, second row has 2 values. NumPy says, no, you can't. I don't like this, okay? It says setting an array element with a sequence. The requested array has inhomogeneous shape after 1 dimensions. Okay, so it's kind of a long, wordy error, but it says, yeah, I don't like this, okay? Because yeah, we have 3 values in the top and then 2 values in the second row. It says, hey, I can't turn that into a matrix, okay? Can't make that. We have a couple handy shortcut functions, okay? So there's a function called .zeros, okay? NumPy.zeros, and this will just create an array with zeros inside, okay? So here I say NumPy.zeros5, it's gonna create an array with 5 zeros. So it's kind of like repeat 0 5 times, like in R, you could say, hey, repeat 0 5 times. The default is that it's going to create floating point values. So you can see these are all 0 dot, 0 dot, 0 dot, because they're zeros and floating point. If you want integer zeros, you can do that. You just specify in your argument, one of your arguments, D type. The data type I want is to be integers, and you can specify that, okay? And then now you'll get an array of zeros, and they are integer zeros. You can also provide a tuple or a list with multiple values here. So here I'm saying make NumPy zeros, and then in the argument, as far as the dimension thing, over here I said I want 5. Here I'm going to say I want 2 by 4. So that's going to create 2 rows, 4 columns. So this is going to create a 2-dimensional array with 2 rows and 4 columns. Okay, so that's exactly what I get, right? You can also create it like a 3-dimensional array if you want to, okay? So this is going to create a 2 by 3 by 4. So this will be 2 layers or 2 sheets. Each sheet is 3 rows and 4 columns, okay? So that's what we get. So here it is. This is what a 3-dimensional array in NumPy looks like, right? And you can tell it's 3 dimensions because when you look at the opening square brackets, you got 3 opening square brackets, okay? And then you have a 3 by 4, and then you have another 3 by 4 to indicate kind of, you know, top layer 3 by 4 and another layer of 3 by 4. Okay. Higher dimensional array. This is a 2 by 3 by 4 by 5. Okay, what is this going to do? So it's hard for us to kind of imagine this, but you know, we're basically going to get 2 3-dimensional shapes. Okay, so we have blocks. Okay, each block is 3 by 4 by 5, and I'm going to get 2 of those blocks. So this is your 4-dimensional array. Okay, so you have a 3 by 4 by 5, which is this one, and then you have a second 3 by 4 by 5 because it's 2 by 3 by 4 by 5, right? So you have a whole bunch of these things. So you have an array, and you got 4 opening square brackets to indicate that this is a 4-dimensional array. So you have that, okay? And then, you know, there's kind of no, I don't think there's an upper limit other than like what your computer's memory can handle in terms of like how big an array can be, right? So, you know, so this array, you can keep going higher and higher in dimensions. I don't know how high you want, okay? You have, just like NP zeros, there's another function called ones, okay? You spell out numpy.ones, and it's exactly the same as zeros, but instead of zeros, you get a 1, okay? So that can be handy. And then if you want to specify a value other than 0 or 1, you can call numpy.full, and then you provide the value that you want. So here I want a 2 by 3 matrix, and the values that I want filled in to be, say, 1.2, okay? Or whatever value you want, okay? So that's how you just create an array of some specified number. All right, let me give you your first view quiz answer, which is the letter E. E as in elephant, E. we can generate random numbers. Okay, so this is often something we need to do in probability and statistics, is generating random numbers. So we use basically everything that deals with random generation starts with numpy.random dot something. Okay, so numpy.random dot something. And so, for reproducibility, anytime you're dealing with randomly generated values on your computer, we recommend setting a seed. And what that does is basically it sets, what appears to be random numbers, but it sets a seed so that somebody else could reproduce the same values that you get, right? So, so setting a seed just says like, okay, we're both going to follow the same kind of random procedural generation, but we want to make sure that we're going to generate the same results. So you set kind of a seed, okay? So you do that. So you do numpy.random.seed, and that's going to set your seed. There's a few other like random state generations where you can specify a little bit more, but yeah, random.seed is often good enough, okay? And that way, when I generate 5 random numbers, okay, so here we're going to get random uniform values. When I do it and you do it, I think we're going to get the same values here, okay? If I run this again, I'm going to get different values. But if I run it, if I set my seed again and I start over, I think we all generate the same values, right? I don't know if you guys are all getting the same things, okay? So this just allows us to kind of make sure we're getting the same things. So random.random, that's going to be generating random uniform values, okay? Random.random. Numpy.random.random, you specify whatever you want, and you get that. And so values between 0 and 1, okay? You can do random normal, okay? Random.randn. Random.randn. Randn will be standard normal values. So centered at 0, standard deviation 1. So what does that mean? It means 95% of your values are between what, -2 and +2-ish, and so on and so forth. So here, when I call numpy.random.randn, I get -1, -1.65, -2.36, +1.13, -1.017, so on and so forth. Okay, and then if you want, you can also call standard_normal. Okay, standard normal will also generate values from the standard normal distribution for random. And then here you can, again, with any of these things, you don't have to just put in one vector or one value to get a vector of those things or an array. You can put in something with higher dimensions, and it'll, here I said 5, 2, and it produces an array with 5 rows and 2 columns. Okay, whatever you want there. If you want to generate values from a normal distribution, random normal distribution, but with a different mean and different standard deviation, you can do that. So this is numpy.random.normal. And here I want mean 10, standard deviation 3, and I want 8 values arranged in a 2x4 matrix. So mean 10, standard deviation 3, I'm expecting 95% of my values to be between 4 and 16. So this is what I get. And indeed, all of my values here happen to be between 4 and 16. Okay? And if I generated more, we'll probably get something like that. Okay, all of these things you can, go to the internet and you can look up NumPy random, okay, and you will get, you can go to random.rand. This is going to just be kind of your manual, and this will be the listing of all of these different random generators, okay? NumPy.random, and oh my goodness, look at all of these things we can do. Okay. All right, so other things that are handy, we have random.randomInt, okay? Here, 0 through 10, so this will basically be from the digits 0 through 9, and I can say I want 20 of these values, okay? And so this will generate digits 0 through 9, so on and so forth. So if you wanted to simulate, say, dice rolls, okay, you want 1 through 6, you want like 50 of them, you can do random.int right there, okay? And then again, here's, I linked here, as far as random sampling, there's a whole bunch of random generation things. So random generator, we have random.rng. Okay. So, okay, simple random data, you can do integers, you can shuffle things. All right, so permutations is if you have something, you can shuffle it in place, and you can do dot shuffle, and then any of these distributions. So you have the beta, binomial, chi-square, exponential, gamma, gumbel, hypergeometric. All right, so any of these things, like if you wanted to generate random values from a Poisson distribution, okay, you can do this. All right, so it has it here, random.generator.Poisson, and so I think this will be numpy.random.Poisson, things like that. So you have some code here. All right. So anyway, anything you want to look up, you can find it there. All right. As far as other things we can do with NumPy arrays, right? So we can create range objects, okay? And NumPy has the a range in an array, okay? So that's a range, okay? So basically a range object, but in a NumPy array. So compare that to just our standard range object in Python. When we do that, you get a range object, 0, 10 by 2. If you want to actually see the values, remember Python is lazy, so when you say I want a range object, it just says, okay, I'll do it when I need to. If you want to force it to, you can say, hey, put all those things in a list, and you can do that. NumPy.arange kind of forces Python to evaluate. arange is not lazy. It will generate the values immediately, okay? And so arange does that. You get the same values, 0, 2, 4, 6, 8, okay? You could put numpy.array and then put the range object in there, okay, and force it to evaluate that way. But yeah, if you're going to do that, just use numpy.arange, okay? numpy.arange is going to create an array with those values. So here's 0, 100, step size 5. So we go, 5, 10, 15, 20, up to 95, so on and so forth. And then, the quickest is just to do numpy.arange and then, what length you want. So numpy arange 20 will go 0 through 19. Okay. So that's why we have that. There's another similar but related but different, and this is called numpy.linspace, linearly spaced values. Okay, and so here you give it the starting number, your stopping value. Okay, here the stopping is inclusive, and how many values do you want? Okay, how many values do you want? So if you want 0 through 100, 11, okay, so you're saying I want a length 11 vector starting at 0, ending at 100, then you'll get values spaced out by 10, right? 0, 10, 20, 30, up to 100 there, okay? Now, you might kind of confuse yourself, right? And you might say like, okay, I want 0 through 100 and I want 10 values, okay? But remember, with linspace, it's going to start at 0, it's going to end at 100, it's going to space these things out equally, and so if the total length is 10, then your step size ends up being 11.11, right? And so, so here this is length 10, but in order to go from 0 to 100, space everything out, with a total length of 10, the length is 11.11, okay? Now, there is an optional argument called endpoint, okay? The default is endpoint is true, and here it's going to produce something that's length 10, and it won't include the endpoint. So 0, 110 endpoint false will end up at 90, okay? But yeah, this, like, you really have to be thinking, because I think it gets confusing when you do 0, 109 endpoint false, okay? The last value ends up being 88.88, okay? Which, it's basically you're doing linspace 10, and then you're just cutting off the last value. But like, you really have to kind of think it through in order to figure this out, okay? So just be careful. I would say just get used to the normal usage of linspace. You know, these optional arguments are there, and you can use them however you want, but probably linearly spaced values, that, you know, that's handy. So that's like if you want to, especially like if you want to kind of create a plot and you want to go from, like, on your x-axis going from like 0 to 85 or whatever, you know, you just linearly space out the values along your x-axis. Okay, arrays, there's a few attributes. So you can say, okay, how many dimensions is your array? So here I'm going to create an array, 3 rows, 4 columns, okay, of ones. The number of dimensions is a 2-dimensional array, right? It's a matrix. We got rows and columns. So the number of dimensions is 2. The shape is going to be 3, 4. 3 rows, 4 columns. Okay, x.shape is 3, 4. This is the shape of it. And then the d type is what kind of values do we have in here? We have floating point values in here, so the d type is going to be float. Okay, and at a technical level, these are 64-bit floating point values. And, you know, technically your computer can also have like 32-bit floating point values, and I don't know, maybe long floats, 80 bits, I don't know. See, but, you know, your typical is going to be 64-bit floating point values. So that's these are the properties or attributes of an array. So 2-dimensional array, the shape is 3 by 4, values there. Okay, so here if I do what is this? Okay, here I'm going to get a 1-dimensional array. Okay, and if you ask what are the number of dimensions there, it's a 1-dimensional array. Okay, it's 1-dimensional. And if you ask what is the shape, okay, if you ask the shape, it is a length 12 1-dimensional array. Okay, so it's not 12 by it's not 1 by 12 or 12 by 1. It's just a length 12. Okay, so you get a tuple with just 12. Okay, so it's length 12. It's not 1 by 12 or 12 by 1. It's just length 12. Okay, we can also reshape arrays. All right, so here I've got a 1-dimensional array, length 12, and I can reshape it into a 3 by 4. All right, I want 3 rows, 4 columns. So what this is going to do is it's going to take these values 0 through 11, and it's going to lay them out. Okay, and when you reshape a 1-dimensional thing into a 2-dimensional thing, NumPy does it row-wise. Okay. R does things column-wise, NumPy does them row-wise. So here we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? This reshape creates a new thing, and it leaves the original unchanged. So if you ask what is J, J is this, okay? We have, there's another thing. So here I called numpy.reshape, and I put J inside the reshape function, okay? There's another thing. You can take J and you can do call dot reshape. Okay, so it's very similar to calling numpy.reshape, but you're calling it directly on the array itself. Okay, this will not affect J directly. Okay, so J.reshape will also produce this thing here. I said I want a 4 by 3, 4 rows and 3 columns, so it does it row wise. Okay. again, the original J is left unchanged. It's still a length 12 one-dimensional array. But you can call J dot reshape. Okay. K is 3 by 4. You can call K dot transpose. Okay. K dot T. This is going to transpose it. So now, the columns become rows and the rows become columns. Okay. And so now I have 0, 1, 2, 3 going down the columns. 4, 5, 6, 7, 8, 9, 10, 11. Okay. And again, K dot T, K dot transpose does not modify the original K. So if I ask what is K, K is still 3 by 4. Okay. So K dot transpose returns basically a copy or like a new object, which is K, the transpose of K. Okay. So all of these things, we can, each of these things that these functions or attributes return are NumPy arrays themselves, so you can chain them all, okay? So here I could say NumPy.arange, okay, 0, 12, 1, and this part itself is an array, and I can call .reshape, and then after I reshape it, I can call .t, right? And so this is going to do one thing, then the next thing, and then the next thing. Python reads it left to right, so it's going to create 0 through 12. It's going to reshape it. So now I'm going to get 3 rows, 4 columns, row-wise. And then I'm going to call .transpose. And so that's going to transpose it. We're going to get 4 rows, 3 columns, but it's going to be 0, 1, 2, 3, 4 going down the column. So when I do that, this is exactly what we get. Okay. All right, here's J. Sometimes you will see in Python or NumPy, you'll see a -1, okay? Sometimes you'll see a -1 as far as the dimensions go, and that feels confusing, okay? But what the -1 is you're telling NumPy, hey, do this thing, but I can't be bothered to figure out what the dimensions are, okay? You're saying reshape J so that I end up with 3 rows, but I don't know how many columns I'm gonna get. Okay. Now in this case it's simple because J, there's 12 values, so if you're going to have 3 rows, you're going to have 4 columns. But sometimes you have this big blob of a something, and you want to reshape it, okay? And you can't be bothered to figure out what the exact dimensions are, okay? So here you're going to say 3, -1, and then that -1 tells Python, all right, I want 3 rows, and just use however many columns I need so that it works out. Okay, and we get that. Now, if I did something like 5 here, right, with a length 12, it's going to say, oh, I can't do that. Okay, you have 12, size 12, and you're trying to shape it into 5, whatever this remaining axis is. It says I can't do that. Okay, but if you say, hey, I want 2, it'll figure it out. 3. That works. 4 also, okay? All of these things, it can reshape, and you just leave it at -1 and it'll figure out the rest, okay? You can put a -1 in any of these things and it will figure it out. So here it says, however many rows you need, I want 4 columns, and it figures that out, okay? Here, I want to make a 3-dimensional thing. 2 blocks, some unknown number of rows, and 2 columns, okay? And then so it'll figure out, okay, I need 3 rows, and it does that, okay? So it's pretty common to come across a -1 as you're reading someone's NumPy stuff when they're doing like reshaping and producing of arrays and things like that, okay? All right, let me give you your next answer. Next answer is B. B as in bear is your second answer. Question 2, B. Okay, so here is a 1-dimensional, all right? The shape of this is just gonna be 12 comma because it is 1-dimensional, not 12 by 1. All right, so here's a question. What is the transpose? If I take y and I try to transpose this, what am I going to get? Okay, you get the exact same thing back, okay? There's no, it's not 12 by 1 and you're going to get, or 1 by 12 and you're going to get a 12 by 1 back. You're not going to get that. It's just length 12, so like, can you transpose that? There's no dimensions to transpose, okay? So, it's like rotate a line in one dimension, and there's nothing to do, okay? So again, when you ask the shape, y transpose dot shape, it's still just 12, okay? Now, what we can't, if you wanted to actually kind of like go from a row to a column, you have to reshape y into a 1 by 12, okay? So here, there's a subtle difference here, but this is a one-dimensional array of length 12, and this is a two-dimensional array with 1 row and 12 columns, okay? And you can see it's two-dimensional because it's got 2 opening square brackets, okay? So the shape of this thing is 1 by 12, okay? So this up here is just length 12, the shape of that is just 12, and this is 1 by 12, okay? So now I can transpose this, the 1 by 12 become a 12 by 1, all right? And then when I say, hey, give me z dot transpose dot shape, then I get a 12 by 1. Okay. So, make sure you can spot the difference between the length 12, one-dimensional array, and then the two-dimensional, which is 1 row, 12 columns. There is a difference there. Okay, arrays we can slice and subset, much like we would subset and slice a list. So here's a length 12. You want the index 4 position. That will be the 5th value. Okay, so that will be the number 4 there. Okay, you can say I want to slice from 4 to 6. Okay, and that will give you just the 4 and the 5 here. Okay. Much like slicing a list does, okay? You can also slice with a second colon, so you can do 1:8:3. The second colon here is basically your step size. So if you slice like that, it's basically start, colon, stop, colon, step. So 1:8:3, you'll get 147. A range 100, that will go 0 through 99. I want to slice up to 100, step size 2, that you'll get the even numbers, okay? 0 through 98, okay? You can also just do that directly by calling a range 0, 100, 2, but here we're slicing. Okay, you can also slice in higher dimensions. So here is a two-dimensional 3 by 4 array. And so if you subset, okay, you're saying I want row index 1, column index 2. Okay, row index 1 is the middle row, column index 2 is the third column. So this is going to return the value 6. Okay, returns the value 6. Okay. When you just pull out only one value, it's not a NumPy array with one value, okay? It is just the value itself. So the data type here is just going to be the integer, okay? It's not a NumPy array. It's just the integer here, okay? Here I'm going to say z 0:2 0:2. So we are slicing the first 2 rows and the first 2 columns, okay? So we're going to get a 2 by 2 array with the value 0, 1, 4, 5. Okay, so here's z, and then when we slice out that section 0, 2, 0:2, we get that top left corner, 2 by 2 corner, 0, 1, 4, 5. Here I want to slice row index 2, so basically my third row, and then after the comma I just put in a colon. I want all of the values. So we just get that third row there. You can also just leave it blank. If you leave it blank without a colon in there, it will work similarly. Okay. If you do something like this, you get back just a one-dimensional array. So this is it's not 1 by 4. We have reduced it. Okay. we have reduced it down to a one-dimensional array. Okay. If you do colon comma 2, we're going to get the index 2 column, so the 2, 6, 10. All right, and again, it has been reduced to a one-dimensional array. All right. An interesting thing is that NumPy arrays, when you slice them, they are view objects. Okay, they are view objects. We are not getting a copy, we are getting a view object of that array. So here's my array Z. I'm going to create, I'm going to slice out this top left corner, 0, 1, 4, 5. Okay. Now notice what happens here. I'm going to replace, okay, so NumPy arrays are mutable, and I'm going to replace this top left corner, the 0, 0, with a 99 in Z. Okay. So Z sub is my view object here. Okay. I replace the 99 in the top left corner, the value in the top left corner to 99, and notice the Z sub is automatically updated. Even though I never redefined it, because it's a view object of the Z, this reflects the change. Okay. So even though I didn't say, all right, show me what Z looks like, and we need to redefine Z sub to be the top left slice. No, as soon as I say, hey, show me what Z sub looks like, it gives me that top left corner. Okay, because it's a view object of the array. Okay. Over here, I'm going to create. So this part might get a little confusing, but here I'm going to say numpy.arange range 3, 5. So here I'm creating an entirely new object, and I'm going to call this thing Z. Okay, so this is an entirely new object, and we are calling it Z here. Okay, so when I ask, hey, what is Z? It's this new thing with 3 by 5. Okay. Now notice Z sub, however, is still the view object pointing to whatever array this was. Okay. Now, unfortunately, this array no longer has a name, and so we can't like access and modify it directly because we don't have a way to really like get a hold of it. Okay. But it's still there, and this thing is still looking at the top left corner of this object back here. Okay. So if I had given this thing a name, another name, we could still kind of access that. But now we don't really have a way to kind of mess with this thing. Okay. If you do want a copy that rather than a view object, okay, you can call array.copy. All right, so here is my 3 by 5. I can call dot copy. So here I'm going to create a new view object. Well, Z colon 2 comma colon 2 is going to create this top left corner 0, 1, 5, 6, but we're going to call dot copy, right? So now this thing is those 4 values in that top left corner, but it's a copy. So here I can change the top value, that 0, 0, into a 55. Okay, the copy is not affected. It still remains 0, that top left corner, whereas the Z has that top left value has been changed to 55. Okay. If you do have a view object and you modify it, okay, so here's my view object. I've changed this top left value to 99. It does modify the underlying value Z there as well. Okay. The type of a view object is a NumPy array itself, and so if you can transpose it, okay, you can transpose it, you can reshape it, all of these things, they're view objects. They don't affect the original thing there. Okay, you can again modify that first value to say 1,000, and it modifies the underlying thing. So view objects, when you slice things out, you get view objects, and view objects are always kind of intrinsically linked to their underlying object that they are kind of viewing. So So you have that. Okay, I will go ahead and give you your final view quiz answer, which is the letter A as in apple. And we'll go ahead and wrap things up here. So have a great weekend, and we will see you next week.